Most coders want to work in big tech, but most coders won't. Most coders want to become good programmers, but the reality is, most coders won't. And the reason why is because a good coder does not equal a good programmer. Think of coding like writing sentences, and think of programming like writing an entire storyline. And if you can't think like a programmer, well, how do you expect to do that? So, this is how to think like a programmer. The black box method. Let's say you need to develop some code that takes in two lists and outputs the merged result of these two lists. A good programmer will immediately think of two things: how to test this code and how to scale it. And notice how we haven't actually implemented any code yet. This is what the black box method is. Essentially, we know the inputs and outputs of our code, but we deliberately don't worry about the internal workings just yet. Now, why is this important? Well, first, it forces you to focus on the bigger picture. By treating your code as a black box, you have clear expectations for what the code should do. For example, if I give it two lists, one containing 1 through 5 and the other 2, 4, 6, the output should be 1 through 6. How the code achieves this isn't important at this stage, but what matters is that it takes these inputs and reliably produces the correct output. For one, this allows you to create test cases with edge scenarios like empty lists, lists with only one item, or repeating elements. And two, this method is essential to help modularize and scale your code. Because let's say you have a much bigger project with several components. By thinking in terms of black boxes, you naturally break your system into several independent parts that interact with each other. This allows you to focus on relationships and a clear goal-driven design when coding. This also means that if one of these boxes needs to be updated or optimized, you can do so without affecting the rest of the system. So basically, the black box method is just a cooler term for abstraction. And as you can tell, abstraction allows you to manage complexity by breaking down a problem into much smaller pieces without getting bogged down in the details too early, which is an essential mindset for a programmer. Collaboration isn't just a soft skill, it's a core skill for any successful program. If you're not good at collaborating with others, how do you expect to ever land a tech job? For example, let's say you need to come up with an algorithm that's going to be reused in other parts of the code base. This isn't something you can just whip up in isolation and call it a day. You need to think about things like how this algorithm will fit into the existing system, how it'll interact with other components, and how other team members will use it. So basically, you need to realize you're not just writing code for yourself, you're writing it for your team. And the last thing they want is to look at your code and not understand it at all. So it's up to you to ensure that your code is clean, well documented, and easy to understand. Make sure you use meaningful names, follow coding conventions, and use comments. Basically, try and make your code as easy to understand as possible. You'll know you're on the right track when your teammates can pick up your code and understand it without needing a deep dive into your thought process. And you also need to recognize that the algorithm you write today might be maintained by someone else tomorrow. So it's important you consider how your coding decisions can impact the team in the long run. Will it be easy to update if the requirements change? Have you built it in a way that makes it easy for extensions or refactoring? And the more you think about these things, the more of a habit they'll become. And trust me, if you can get in the habit of making readable and adjustable code, you'll already be thinking more like a programmer than a coder. Improve the wheel. This one might be controversial, but in my experience, a good programmer knows when to use other code for their advantage. Now, when I say use other code, I don't just mean use ChatGPT to write your whole project. Let's say you need to develop some sort of user authentication system. You could spend weeks or even months developing this from scratch, but why do that when there's countless well-tested libraries and frameworks like OAuth or JWT which have already solved this problem? So basically what I'm saying is, you need to get in the habit of using tools like these to solve your problems for you. It's not about being lazy, it's about being smart. As a programmer, your time and energy are the most important things you have, and they should be spent on the parts of the project that truly require your unique input. But let me be clear, using other code doesn't mean just blindly copying and pasting without understanding what's happening under the hood. You should always take the time to learn the tools you're working with. This way you're not just assembling code, you're building a deep understanding of the systems as well. Now, some might argue that using pre-built libraries or frameworks means you're not really learning or improving, but that's not true at all. In fact, by using these tools, you're exposing yourself to the industry standards and new ways of thinking. You're learning how to integrate different components, how to read and understand other people's code, and how to make informed decisions about which tools are right for the job, which are all essential skills to think like a programmer. Think in terms of processes. If you're a beginner, you've probably spent the majority of your time mastering one or two programming languages. And this is great because it helps you build a strong foundation. But what happens when you need to learn a new language? Because let's face it, every company uses different technologies, and you'll inevitably need to adapt. The key is to think in terms of processes rather than just code. Because when you focus only on the specifics of one or two languages, you limit yourself to that language's paradigm. But programming is more than just knowing how to write for loops or functions in Python. It's about understanding the underlying concepts and methodologies that are used everywhere. So, you need to start by really understanding the different possible solutions for a problem before even thinking about the code. For example, if you're asked to build a feature that sorts a list of items, instead of immediately writing code, think about the process. What's the most efficient way to sort this data? What are the trade-offs between different sorting algorithms? Or let's say you get asked to create a class that can insert and remove elements. You need to think about which data structures will be best fit for your specific constraints and specifications. These are all examples of what makes a good programmer, knowing what to use and when to use it. And if you get really good at understanding these processes, figuring out how to apply it into code will become 100 times easier. Because from here, all you have to do is convert your process into the specifics of whatever language you're using. And it's also important to understand that your first processes might not always be the best. So it's up to you to be willing to iterate on your ideas and adapt your approaches. Because overall, if you want to think like a programmer, you need to be willing to adapt to new ideas and change your existing ones. Let's talk about something that can make or break a programmer: failure. In programming, failure is not just inevitable, it's valuable. Every error, bug, and failure to solve a problem is one step towards your learning. You see, pretty much everyone at every level makes mistakes, and it's impossible to write perfect code all the time, which is why you need to start seeing bugs as an opportunity to understand your code and to better improve it. You need to recognize that failure isn't a setback, it's feedback. When something goes wrong, view it as an opportunity to learn from your mistake. This mindset is crucial because programming is all about problem solving, and real-world problems are often really messy and error-prone. So instead of viewing failure as a roadblock, if you really want to be a good programmer, you need to continuously improve on your failures and not be discouraged. Overall, I hope I helped you gain a better understanding of how to think like a programmer.